All right, guys, so here we are on page 4 of the IS number 14 notes. This is the big ideas and check your understanding for part 2. So first we're going to talk about interpreting confidence level. So this refers back to learning target number 2, which is to interpret a confidence interval. Part of that confidence interval is the confidence level. So we're going to set those two apart. So here we are interpreting a confidence level. Okay, so to interpret the confidence level, this is similar to what I was typing on the previous page. We will say if we take many confidence intervals, we expect about C%. C again is your confidence level. So C% of them. And again, I'm going to use that word that's different from the one in your book. We're going to say to capture. So about C% of them to capture the true parameter. And I'm going to write it a little bit different this time because I want to emphasize that for us, that parameter is either going to be the population mean or P, the population proportion. Okay, so that is our interpretation of a confidence level. We want to keep that straight. We don't actually have to take a sample in order to interpret the confidence level. For every 95% confidence interval, we're saying that if we took many confidence intervals, we expect about 95% of them to capture the true mean or proportion. Same thing for 80%, for 70%. Hopefully we're not doing a 70% confidence interval. We don't want one that has that low of a confidence level, but all the way up to 99% as well. Okay, so now let's move on to learning target number 5, which is about what affects the margin of error. Okay, so we kind of played around with different sample sizes and different confidence levels, seeing how that affected our confidence intervals. And of course, our confidence intervals are built using the margin of error. We add the margin of error to the point estimate and we subtract it. So when our interval length is being affected, it's really that margin of error that's being affected. So let's summarize what we figured out on the previous page. If we increase the confidence level, then we also increase the margin of error or the interval length, right? Whenever we made our confidence interval higher, we had to have more value so that we had a better chance. Better chance of actually of our single interval actually capturing the parameter. On the other hand, whenever we increased the sample size, that actually decreased the variability for us, and so that decreased our margin of error, right? The larger sample size we took, the more accurate we could be, and the shorter our interval would be, which meant we had a smaller margin of error. Okay, so the last thing that I do want to point out, and this doesn't really relate to any of the learning targets that I listed, but we just need to keep it in mind. Margin of error never, ever accounts for bias. So if the way that you gather your data is biased, or if you're using a sampling method that's not sound, for example, a convenience sample or a voluntary response sample, having a large margin of error does not make up for that. If the data was collected in a biased way, then you're still going to have bias in your results, regardless of what you do to try to make them better. Okay, so let's move on to the check your understanding question. It says, as part of a project about response bias, Ellery surveyed a random sample of 25 students. Okay, so I'm instantly thinking, good, it was random, 25 students, so N is 25. One of the questions in the survey required students to state their GPA aloud. Oh, I don't know if you guys would be willing to do that. And based on the responses, Ellery said she was 90% confident. Okay, so I know my confidence level, right? My confidence level is 90. So she's 90% confident that the interval from 3.14 to 3.52, there's our interval, captures the mean GPA for all the students at her school. Look at that. It's a very nicely interpreted confidence interval using that same sentence that we were using on the previous big ideas. And we then know also that our parameter is the mean GPA. Okay, so it says to interpret the confidence level, not the interval. That was just interpreted right there, but the confidence level. So we're using this sentence up here. So we'll say if we take many, many confidence intervals, if we take many confidence intervals, we expect, okay, let's remind ourselves that the confidence level, it was 90%, right? So we expect about 90% of them will capture the true mean GPA. Again, I'm filling in whatever that parameter is. Okay, the only other thing that I want to put in here is that these are specifically 90% confidence intervals. That makes my interpretation just a little bit more specific. Okay, so then it says, explain what would happen to the length of the interval if the confidence level were increased to 99%. We saw that on the previous page. If we increase the confidence level, the interval gets longer. So we can say that here. It would widen the interval or make it longer. And I just want to make the connection to margin of error. Oops, sorry. So make it longer because the margin of error would increase. So whenever that confidence level increases, so does your margin of error. Okay, so then it says, how would a 90% confidence interval based on a sample size of 200? So there's our difference. Instead of 25, we're at 200 compared to the original 90% interval. So we've gone from 25 to 200. We've increased the sample size. If we increase sample size, then the margin of error decreases, so the interval is going to get shorter. So the interval would be narrower. How about shorter? Just to be really clear. And again, because increasing the sample size decreases the margin of error. And I'm going to abbreviate this time, MOE, margin of error. So our interval will become shorter. Okay, so last question. Describe one potential source of bias in Ellery's study that was not accounted for by the margin of error. So if I look back up at the question, I kind of paused when I read this. It says one of the questions in the survey required students to state their GPA aloud. So it's as if I went around the room and asked every one of you to say out loud what your GPA is. I can imagine that all of you might not be honest, and the interval kind of makes me think that as well, right? It's pretty unlikely that the average GPA in a school is above a 3.0, just in my personal experience. So I'm thinking that the students stating it aloud, they probably weren't totally honest. And so we have a source of bias there. So that's what I'm going to say. Students might not tell the truth, right? They might state a higher GPA than they really have about their GPA when stating it aloud. Okay, so that's it for talking about confidence levels and then how the confidence level and sample size work together to influence the margin of error. So check out the next video for part 3.